author of the Universal Model, and that's kind of what we're talking about. How many of you are familiar with this already? Okay, most of you are a little bit. All right. Great. And we used to have a team of people that would do meetings like this, and we did it for about 2 years, and then they actually published the book, and I guess Dean and his staff was so busy that they kind of stopped doing meetings, and they're trying to just do it all on the internet. But I really like the opportunity to see people and talk to them face to face, and show them rocks, show them the book, and we have the book now that we can actually show people and hand it to them. So I really thought it was important that we get this going again, and so I kind of decided on an idea of doing it kind of simplified version. Some of those meetings used to last 2 hours, and I thought, let's just do a little hour presentation. And actually, I think I can finish before the 8 o'clock hour, so we won't go overtime. But and especially because this week is really more of an introduction to the So I'm going to be talking about some of the high points and some of the important aspects of it. And then my plan is next month, then we'll have a very brief introduction and then go in more detail into some of the chapters. My plan is next month to cover the introductory chapters. There's 4 introductory chapters. And then there's 5 science chapters, and so I plan to do those in consecutive months after that. And some of those chapters are really big, and like I say in these other meetings, sometimes we would spend 2 different meetings doing them, and we'd have 4 speakers all taking pieces of it. And so we're not going to go into as much depth, but my plan is to go through each of those chapters and at least give you the high points of it, and then to go back and then maybe go into more detail, subchapter by subchapter if necessary. But anyway, so I like I say, I'm very glad you're here. So Universal Model, New Millennial Science. Is the audio coming through now? Okay. I'll just keep going here. So let's see. Oh. Okay, there we go. All right, so what is the UM? And I already kind of talked about it. The UM is the Universal Model, a New Millennial Science. And so UM is short for Universal Model. But a New Millennial Science is, let me just show you. Of course, it's a book. The research began back in 1990. And it was digitally available in October 15th of 2016. And then the printed version came out just a little less than a year ago, April 6th of 2017. And so that's when we first had these hard copy books. And as you can see, this is volume 1, which is the Earth system. So that's all about geology, and that's why I've got a display of a bunch of rocks here and over there. And let's see, why is this skewed so much? Maybe we let's see, I guess I don't. Sorry, new projector, so I don't know how to mess with that too much. I don't think I want to play with it too much. Okay, so let me talk about the purpose. I actually teach here at the school. Do any of your students have me as a teacher? Somebody said their kids are here. Your kids are here, okay? So, okay, they're in. All right, so they're in some of the regular classes, but I do an elective science class here. But anyway, the purpose of learning science, I feel, is to search, describe, and explain so that we can comprehend nature. Search, comprehend. Let me start that again. Search, describe, and explain nature so that we can comprehend and understand truth. And so truth, I think, is really important. And this kind of shows some of the stuff we'll probably talk about next week in more detail about the learning model. But I've seen a lot of signs like this up lately. Tuition-free, K-8 education, award-winning tuition-free, right? All these charter schools popping up. This one is not a charter school. This is a private school, so people have to pay to come here. But the question I have is, how many parents want their children to go to school and learn falsehoods, lies, right? I mean, would you send your kids to school to learn something that isn't true? And yet, that's what I feel like we're getting a lot out there in some of these public and even the charter schools. So the question is, why do we need a new universal model of science? And it goes back to the big picture of modern science, which basically says that we started from nothing, and then all of a sudden there was this big bang explosion, and somehow that organized itself into all of the chemicals and elements and the solar system that we have, all of the galaxies in the universe, right? And then somehow, although it's not explained how we take this leap, somehow something comes to life, and we have this little one-celled bacteria organism that then evolves into all of the plants and all the animals, and then apes, and then to us. And that's what public school is teaching everyone. And that's what our colleges and universities are teaching. So, I don't know how many of you may believe that, big picture modern science, but I can tell you I don't. And I mean, just the fact that did everything really come from nothing? Pretty big question. I mean, when have we seen something coming from nothing? And how does that whole process work? So Dean Sessions, the author of this book, started asking a lot of questions. He started seeing some things in science. I think he first, actually that probably comes up here. So this has created a crisis, and the crisis is that we really need to have textbooks that have other options, other solutions. And one of the crazy things is there's a website called The Third Way, I think it is, that is asking people who recognize that evolution has failed to explain the scientific process of mankind's life. And so they're asking, well, we don't like, what creationists say. We can't tolerate that. And we thought evolution was going to work to explain life. And that hasn't really worked out because the scientific evidence just isn't there. And the research is showing that doesn't work. And so now they're asking, we got to come up with some other way. We need a third way, a third choice. So anyway, it's kind of interesting. But as we look in science, there's an interesting book here, 100 Scientists Who Shaped World History. Okay, so that's the cover of the book. And one of the things that was done in writing the universal model is we went through all of the people in this book, and we plotted them out in the time frame all the way back to 500 BC is the first scientist that's mentioned in this book. And we categorized their scientific discovery in 4 categories. And let me zoom in on the top part of this. We've got new observations, new technologies, new theories, and new laws. So the scientific laws. And let me just go back here, because you can look all the way up into the were tested and either became natural laws or they were discarded. You know, maybe it was a nice idea, but it didn't work, right, when we tested it. And so during, hundreds of years of our history, we're not stuck with theories. But then we start to come up with theories, and those theories are what's sticking. We've got Charles Darwin with the theory of evolution. We've got the Ice Age theory, okay? Theory of psychoanalysis with Sigmund Freud. Here's Albert Einstein with his theory of relativity, right? So were these experimentally proven? And the answer is no, they weren't. So we're kind of stuck with all these theories, and so the book claims that we are now in the dark age of science, because for the last 100 years, there's been no new scientific laws. And that's pretty shocking, right? Because all during, this period, we have all of these scientists that are producing scientific laws. The 3 laws of motion from Newton, right? And all of the Kepler, Galileo, some of those. So we have these scientific laws, but now the scientists say, well, all you need is theories. Theories are kind of like laws. They treat them as fact, and they're teaching them to our children as if they are laws, if they're fact, proven scientific theories, but in reality, they're still just theories. They're somebody's idea, and it's a way of explaining it, but again, we should be testing it to decide if it becomes a law. And so that's why we're saying we're in the dark age of science, and that's why we're saying we need this book. And so the universal model then goes forward to try to create new scientific laws and come forward with those. And it actually has come up with dozens of new scientific laws, which is incredible when you think about them. So this is what we see as the picture of modern science. The modern science puzzle, right, is hard to comprehend. And if I gave you these pieces of the puzzle, there's no way that you could put this back together just that way, at least unless you were maybe looking at it. You might be able to do it over a long, long period of time, right? But this is a picture that you can understand, right? A picture of nature that is clear and understandable, and we can kind of see where the trees and the steps and the plants are all there. So this is nature's puzzle. Science has little bits and pieces that they've put together, but they're kind of disjointed and don't really work together. And several pieces are missing, right? So we're trying to get more to this over here. And that's kind of what the universal model, I think, is trying to do. So the UM actually started with some curiosity about arrow points, which is kind of fun, especially because in Volume 2, he gives a lot of information. This is the future cover for Volume 2. We do have this available in the digital format, so you can read. Actually, I think there's one more chapter coming, but if you buy the digital, you'll automatically get that last chapter that's coming. But anyway, that's an excellent book and worth the read. And so that will be Volume 2 when that comes out. And he talks about the arrow points and how they fit in and kind of where the cultures came from. Kind of maps it all out. It's very interesting because he continued with that research. So the universal model, though, it contains hundreds of new scientific discoveries across many natural science fields. We mentioned earth science with Volume 1. In Volume 2, the living systems and explaining fossils and how they're made and when they were made and And then going into volume 3, that's the universe system. And that's not available yet. Actually, let me go ahead and show you here. This is kind of a table of contents. So this is a quick summary of all the chapters and goes through the 3 main sections. We have the Earth system with 5 science chapters. The universe system, the living system is volume 2. And then the universe system, volume 3. And in that, he will be redefining mass, length, time, and really redefining the periodic table. He's going to be changing it all. So it's pretty wild. But it's nice because he is very careful about defining things very clearly and simply so that people can understand it. And it makes that nature's puzzle all fit together. And then the futurity system will probably be published with the universe system, and that'll be coming out soon. This is actually printed in the front of the volume 1, so if you wanted to look at that closer, you can, because I know you can't read it on my screen here. Oops, I went back. Okay, so the universal model has extraordinary discoveries and claims. And an extraordinary discovery is something that would have to make us rewrite textbooks, right? If you make a discovery that is so revolutionary, it's going to change all of science. And so we'll talk about some of those and show you some of those. So we'll start with the Earth system. And one of the things, there's a big crater in northern Arizona known as the Arizona Meteor crater, right? Are you all familiar with that? So what if we told you that the Arizona Meteor crater was not from a meteorite impact? I mean, that's kind of like, really? I mean, it's in the name. It's on all the signs, right? But the universal model makes that claim, and it makes it very strongly. So if you want to talk about that, we can. So the Arizona Meteor crater is not from a meteorite impact. Most rocks do not come from a melt. And let me just show you this one. So this is basalt, and a lot of the black mountains around the valley here are basalt. Up in Flagstaff, right? You've been by the big mountain there. All right, and so that's considered a lava rock, right? But would you be surprised if, what we did is we melted part of it. So feel the comparison. The basalt is pretty rough, but how would you describe that? Glass, right? Okay, and so this is a pretty quick, simple experiment that the universal model has done because basalt is supposed to come from lava, from a melt. And yet if you melt it, it looks completely different, feels completely different, right? Its makeup is different. And so the universal model goes on to explain that it was from a volcano, but this volcano erupted underneath a flood. Okay, so it was in a high-pressure environment in the bottom of a flood. And that's why I have it over here with the depth mark, which we'll talk about later. And it's true of most rocks, because if you have a melt, like glass, right? We know glass comes from silica that's melted, sand, if you will, right? But sand is made up of crystals. Right, little quartz crystals and stuff. So it has a very organized, orderly structure, and it's very different from the glass, which is amorphic and has no real order or organization to it. It's just been melted and then cooled. Okay, so very different. Okay, fossils can form in days. It doesn't take millions of years. And to talk about that, I have a crystal here, and I asked my class, how long would it take to form this crystal, And, they're talking thousands of years, or, some people might say millions of years, right? Anyone want to guess how long it take to grow this crystal? Okay, good. And I'll actually pass this around because this one you can see has a wire in it. So what they did, they actually wrapped a little piece of quartz crystal and in wire and put it in the right environment, and it grew to be that big. Now, thank you very much, Rose. So let me show you this diagram. This comes out of the university model here. And here's a crystal that they wrapped in wire. One day later, it had almost doubled in size here. You can see this one is not quite touching that wire there. So if it went from there to about there on that side, and about the same length on this side, in one day. Now this was at 13,000 pounds per square inch, right? So if we think of a square inch, right? And you've probably swam in a swimming pool, and so you have dove down and felt the pressure in your ears, right? Well, how deep do you think your swimming pool has to be for you to get 13,000 pounds per square inch? Yeah. So the calculates it out, about 5 miles of water. You have to be that deep in order to form a quartz crystal. So this particular one actually came with a sheet of paper that said it was more than 10,000 pounds of pressure. They actually said they kept it in the autoclave for about 9 months, just to be open on that. But anyway, months, days to months, rather than, thousands or millions or billions of years, like they say. Okay, and let's go on here. Okay, so, and one of the reasons that this meteorite crater is so important, because it's actually on the cover of a book that talks about the age of the earth. And that is the book where they claim the age of the earth is 4.5 billion years old. And so they actually used what they thought were meteorites from this crater to determine the age of the earth as 4.5 billion years old. So if this is not a meteorite crater, then their whole theory is out the window and doesn't work. So the whole age of the earth changes. Yeah. So I won't really today, but the carbon dating would have to be on something that's living, so like a piece of wood, right? So yeah, it is, but it is in volume 2. It's in volume 2 where they talk about the age of the earth and stuff. Oh, okay, thank you. All right, so she asked how they're doing carbon dating here and how they're figuring out this 4.5 billion years old from the crater. So what they did was they're looking at radioactive elements that they found in what they thought were meteorites. So the iron, nickel meteorites that they find, and they're dating those elements and the radioactive decay of those elements. So carbon dating is one form of radioactive dating, but that only works for living things or things that were living at one time, and it only goes back maybe 30,000 years, I think. Because of the rate of decay of carbon-14. And so to try to date things further back, they use other radioactive elements, and so they would be like, uranium or iron, nickel, radioactive forms of iron and nickel and those elements. And they're finding them in what they think are meteorites around this crater. But we kind of show that those aren't meteorites. So thanks for the question. Okay, here's some more Earth science questions. So this is more from the Universal Model here, Volume 1. Most of Earth's sediment is not from erosion. So the idea that sand over here, comes off of the Black Mountains and rolls down and then forms these things, doesn't really work, especially when you have like this pink coral sand I'll pass around. This is pink coral sands from the sand dunes up in southern Utah. And if you look at this under a microscope, and there's pictures in here to show it, you can see that it's quartz-based crystals. They're like clear little crystals. And it has some of that reddish coloring on the outsides of them, but it's not like that's all the way through the sand grains. And so these sand grains are coming, actually forming as crystals in the flood and settling down in big fields. They didn't erode, so they're landing where they're being found where they landed after the flood, rather than being washed down from mountains and breaking apart. And he actually shows research in the book about how there's several sizes of sand grains that are missing. So, if it eroded from mountains, it'd break smaller and smaller and smaller, and so you'd have all these different sizes, right? But no, there's some sizes that are missing. So okay, there's no magma inside the center of the Earth. Again, this experiment kind of shows that, because the theory of science on the Earth, the formation of Earth, is that all these rocks started hitting into each other. It's called accretion, and they kept hitting into each other and sticking together instead of bouncing apart like everything happens in life that we know. But they somehow stuck together. And finally, maybe some big giant thing smashed into it, enough so that it melted the whole big ball of rock. And somehow that rock has stayed hot on the center over 4.5 billion years. So anyway, if it had all come from a melt, we'd be walking on glass. But instead, nearly all of the rocks found on the surface of the Earth have some form of crystal, like a quartz-based crystal. Okay. So the first chapter, science chapter in the Universal Model, is called the Magma pseudo-theory. A pseudo-theory is a false theory that is taught as fact. And how many of you were taught that there's magma inside the center of the Earth? Unanimous, right? You too? Were you taught? You don't remember? Okay, not sure. And did you raise your hand? Okay, yeah. Okay, you were too, right? All right. So pretty much unanimous. All of us were taught, and we were probably taught like it's a fact. Everybody knows there's all the pictures on the internet. Of course, nobody's been there to see it. But anyway, so that is a completely revolutionary claim. And I've talked to some people, and they just say I'm crazy when I start talking about that stuff. But the more you read the book, and you see the documentation, because he quotes thousands of authors, thousands of scientists, and on each page here, like there's blue sections. All of these are quotes from other scientists, okay? So the blue quotes make it real easy, and there's footnotes, so you can go track down the articles if you want, and you can read it for yourself. And I just turned to a random page. nearly every page has blue quotes on it. So so he really goes through methodically. I mean, he spent 27 years writing this, so he's done his homework and has the research there to back it up. Okay, so let's see. Here we go. Okay, the Earth is a hydroplanet with an ice core. So again, 180 degrees change, right? We've got from molten magma. Actually, if you're measuring it in temperature, it'd be a lot more. I would say 180 degrees just because it's a complete shift of thinking. But if you measured it in temperature degrees, it'd be even more than that, because they're saying molten rock in the center of the Earth, right? And we're saying water, and then the solid core in the center is ice. Okay, so completely different. But it's interesting that NASA is coming out with all these articles and all this research where they're finding all these, what they call water worlds. And like the moons of Jupiter and Saturn, they're finding water in all these places. Mars, you've seen the articles, right? So, but they just don't think there's that much water here on planet Earth, which, you know, most of it has oceans, right? So, the largest rock formation on the Earth is a salt pillar. So that's pretty wild. Bigger than Mount Everest, one solid mass of rock that is salt. It's down like in the Gulf Coast. We actually store the United States stores its petroleum reserves in this salt pillar. And so we've dug these big barrels out of the salt, and that's where we store our supply reserve. Yeah. So yeah, it goes underground. So it's not as high as Mount Everest. It goes down probably as deep. So yeah, pretty wild. Okay. All right. Any questions about Earth system? I think I'm just about ready to go on to the next. Go ahead. Love it. I would say yes. Yeah. I mean, there may be a few exceptions, but you know, certainly quartz and nearly all questions. Oh, you ask, how do all crystals need water to form? And I don't know as I want to say all, because you get yourself in trouble when you say stuff like that. But all the crystals I know of require water. And pretty much require this hyperthermal environment where you have that high pressure, more than 10,000 degrees of pressure in this oven circulates the water through the pipe so that the minerals are circulating, because it's hotter on the bottom than it is on the top, and so there's convection currents going through. Yeah. So we're saying that it's a hydrofountain crater, kind of like a geyser, or what a lot of us think of as volcanoes, but not lava, but an eruption of steam, because when water changes to steam, you could have this much water, and it changes to steam, it's this much. 1,700 times the volume. Okay? And if we've got rocks, you know, like on an earthquake fault line that's causing the rocks to heat up down underneath the earth, that can change, a lot of water can change the steam very quickly and blow the top of a mountain off, like Mount St. Helens is a recent example of that. What was your question again? Oh, no, you asked what meteor crater, you said that we told you what meteor crater is not. We said it's not a meteorite impact. And so he asked, so then the natural follow-up question is, what is it? And I'm saying that what is called meteorite crater is a hydrofountain crater. So it was an explosion from inside the Earth, and it erupted out. Yeah. Right. Right. Yeah, so there's a weak point. Yeah. Yeah. Yeah, good. Thank you. Okay. So I'm going to go on now to the living system. And I mentioned the arrow points and stuff, and he talks about this Clovis culture because their arrow points are so unique, named from Clovis, New Mexico, but you can see they cover most of the United States, what is now the United States, and centered in this area. And their arrow points are very long, very finely chipped so that they are in very fine rocks. And they have this flute, this channel, a groove that runs the whole length of the spear point or arrow point, and that allows them to strap the wood to it. So it's an effective method. And so we're talking about the living system here. Let me cover some of the extraordinary claims, right? That's kind of the way I've decided to review the universal model today. It's just kind of going through and talking briefly about some of these revolutionary claims. So petrified wood and fossil shark teeth are not being formed anywhere on Earth today. When a shark's teeth fall out and they lose lots of them in the ocean, they just decay and disintegrate, turn to powder. And petrified wood, you know, the scientists make it sound like we can take a piece of wood and put it down underground and dig it up maybe 1 million years later, and we'll have a piece of petrified wood. But is that really happening today, right? If that's happening today, we could dig up wood and we'd find it petrified, right? So the conditions that these things petrified in, here's a little fish fossil, right? So the question is, how were these formed? When were they formed? And based on this experiment, Dean Sessions has actually used this same process, this same experiment, and has made a piece of petrified wood. Right? 45 hours. Okay, yeah. Yeah, 45 hours, right. So it doesn't take millions of years, right? And here's, I mentioned shark teeth. These are some that I got recently. He even talks about the colors of the shark teeth. And do I have that? Yeah, I have that one here. The colors of the shark teeth depend on the temperature. So these probably got up to 350 degrees centigrade because these are black shark teeth. And you can take them out of there if you want to handle them. But other fossilized shark teeth may be at lower temperatures. And he's kind of figured that out. Here's his experiment where they disintegrated or dissolved in different solutions. And so he's showing how they're different if they're fossilized and have changed into stone, right? That's the difference between a fossil and not. The petrified wood is actually changed into stone. Okay? And the bones that are fossilized have changed to stone also. And that's a crystallization process. So under 5 miles of water, you have enough pressure to force the silica-rich minerals into the cells of the wood so that crystals can start growing inside the cells and then change it to petrified wood. But that means there must have been a time where there was 5 miles of water above the surface of the earth here in Arizona, because we've got the petrified forest right here on the surface of the earth, and the only way that could be crystallized is under 5 miles of water, because that's the only conditions that quartz crystals form in. And let's see, where's my other here? So let me pass around this piece, because this one actually, you can see the brown and black wood, and the bark has kind of been pushed out so that there was a space where there was more water, and the quartz-based crystals, the lighter milky quartz crystals, are in and around it. So a rock similar to this one is what helped Dean Sessions realize that it's the exact same conditions, right, that formed quartz crystals, because you've got quartz crystals all in and around the petrified wood. So obviously the same environment, the same conditions. In fact, we call it hyperthermal, because hyperthermal is just, or hydrothermal is just water that's hot. But you need the pressure in there to make crystals form. And so, and that's why how they become so hard, is that pressure. So we call it hyperthermal conditions, and it's basically under the 5 miles of water of the flood. And that's how most of the rocks on the surface of the earth form, and that's why we have these 13 marks of the flood. I actually do a presentation with my students, and I help them make a little rock kit like this. Noah's flood is a fact, the rock-solid evidence. And so you can have, there's 13 marks of the flood. One of them is diamond. And I figure the kids aren't going to have diamonds usually in a little rock kit. So I figured we could teach them all the marks of the flood with a little rock kit of their own, where they can collect them and do them. And that's actually back in Volume 1, Chapter 8. And you can come up and look at that display a little more later. I don't think I'm going to have time to get into it much today, because I'm running out of time here and need to hurry. All right, the oldest human tools are not the most primitive. Like I mentioned, those Clovis points are the most finely made arrow points, and they're actually the oldest ones. So that represents the Clovis culture is the oldest culture. Evolution is wrong. Okay. Any questions on living system? I'm just kind of hitting some of the biggies, but there's a lot more there. I'm going to go on to the universe system. And in the universe system, most of the moon's craters are not from an impact. And I think he says maybe there's 5 or so craters on the moon that are actually from a meteorite impact. And a lot of them you can actually look at the pictures. Actually, here's pictures of the moon, right? So ones like this, you can see that there was an angle of impact, and the V formation of the spray. Okay, so that one right there is from a meteorite impact, right? But a lot of the craters, like they have craters, and there's craters within craters, or craters on the rim of the craters, and the craters in a line, like it's on a fault line, right? And those kind of craters, you just got to be thinking, that probably came from water, right? Because meteorites aren't going to hit in the same place twice, right? But if you have an eruption crater, then like a steam explosion crater, then it makes a lot of sense now that rock has been broken once, then you have another little steam explosion, it could come right out the side here, right, where it's weak. Because that's the way explosions work. It's going to find the path of least resistance. Okay? So what is the most famous equation in science? Yeah, E equals mc squared. So is that true? No, sorry. The most famous equation in all of science that everyone knows, and it doesn't even work. There's no experiment that we can do to prove that that works. Kind of sad. So volume 3 is where he'll explain that. Oh, so E is for energy, and he is equating energy with the mass times the speed of light squared. Okay? Yeah. So you square that, multiply it times your mass, or the mass of the object, and that equates to energy. That's what Einstein was claiming, right? But he really didn't do experiments. I actually did an experiment with my students where I could show that the speed of light is not constant. So that's one of the problems with this, is that the speed of light is not a constant. I mean, that's why it's c. It's supposed to be constant. Okay? So he has some experiments to show that the speed of light is not constant and it changes in the different mediums that it's going through. I mean, it changes just based on the humidity in the air that day. Right. Yeah. So totally revolutionary. Let's see. Oh, and this Na and Cl. This is sodium chloride. That's, like on your periodic table, it would have this abbreviation for sodium and chloride. And so salt is made of sodium chloride. Maybe this isn't quite said quite right, but it's not like you can take a vial of chlorine gas and a chunk of sodium metal and put those together and it'll just make salt that you can eat. Okay? And that's what the chemists claim, but it doesn't quite work that way. So sodium chloride is salt, but it doesn't make it the way they claim. Modern science Earth density calculations. So, and we're talking about off by a magnitude of 3 times the mass of the Earth. So it's a big amount, and so we're saying it's wrong. It's lighter, right? Because they're claiming it's based on an iron-nickel core, so a very heavy metal core. Let me go ahead and pass this rock around so you can see it. Right, pretty heavy. That's from my ore here, so that's some heavy metals in the ore. Right, so yeah, if you had that much volume of water, it would not be that heavy. And so that's kind of showing some of the difference, but that's some ore. Okay, let's see here. Any questions? There we go. Okay, so modern scientists have not discovered a new natural law because they're not even looking for them. They think, in fact, I think maybe they're not even looking for them. And like the next slide says, theories are the end point of science. That's what the National Academy of Science is telling us today. That the theory is the end. We say that's the beginning. That's the first step, right? You have this idea, this theory of what works, and then you have to go test it. But they're saying the theory is the end. So, I mean, anyone can make up a theory, right? Okay, why will the universal model be accepted by many without coming from a university or government institution? And it's because we believe that truth is independent of its origin. So it doesn't matter if it's coming from a government agency, some science organization, a science department at a university. That doesn't matter. I mean, you can read the book for yourself, and you can check out all the quotes if you want. You can, see it and read the arguments, and I think that you'll probably be convinced, like I have been, that this is the truth. And that truth stands independent of where you're getting it from, right? So, because you can look at it in other ways, in other places. You can do experiments. You can test it. And so, it doesn't matter what Dean Sessions says or what his book says, right? you can actually go and investigate for yourself. Like that quartz crystal, the big one with the wire in, came from a lab. This is actually the lab that produced that. And I got these at the Tucson Gem and Mineral Show. And he actually found the crystals like this, on the inside of his autoclave at the lab he was working at for computer science. Developing silica chips for computers and stuff. And so he made a proposal to him and said, hey, could I use this? Could I rent one of these and use it to make crystals? And so he's been making crystals, and he's formed a lot of really beautiful crystals. So I'll go ahead and pass around these. Some of them very delicate. He has ones that are much bigger and more beautiful. I could only afford a few. And this one actually is an anhydro. So this is a man-made anhydro. And this one is a anhydro that is natural. This one came from China. And if you'll look on the biggest surface here, right in this area to that side, there's kind of a dark, dirty area here. But over on this side, there's a little pocket that has a bubble in it. And if you tip it back and forth like that, you can probably see that bubble moving. Okay? Yeah, there's water in it. Okay, so it's water trapped inside the crystal. And that's an inclusion. It's called an anhydro. Do you want to take my phone and show the light? Because that looks really neat with the light too. And I'll do some of these. All of these here have water inside. Let's use this one. Yeah, you can kind of feel it if you shake it. So hold it real firmly in a few fingers like that. Shake it up by your ear, see if you can hear it. And then if Spencer can bring the light, he probably wants to show on that crystal as well. Okay? And you should be able to see the water inside there.
Oh, yeah.
Right? Yeah, that side shows real well. Okay? Yes? So as the crystal's forming, it actually traps some of the water that is formed in. And so who knows when that was formed? So I guess I'll just go ahead and say that we are claiming that most of the crystals and rocks on the surface of the earth were formed 4,363 years ago when Noah's flood happened. And so the water inside these is water from Noah's flood. And it was trapped in those rocks from that time, because that's when those rocks formed. And one is a amethyst crystal. That purple one is an amethyst crystal, so it's similar to quartz, but not exactly the same. And the other one is, they realized that there was water inside, and so they polished the outside of it. Okay? And if you think about these rocks that have water in, right? If we had an ice age where everything was frozen, right? Would we still have the water trapped in those? They would have broken, yeah. The ice would freeze and expand and break. And we have bought a lot of anhydros that, we got them either too hot or too cold, and they've broken and the water's escaped. Mm-hmm. And then the other thing is, on the other extreme, right? If our planet was a big ball of magma at one time, is just a big melted, molten ball, then how would we have water trapped inside the rocks? So those kind of disprove those erroneous theories, right? And you've seen it, and I've got some more up here. All right? And so truth is independent of its origin. We can find it lots of places. And so my final question, what is the UM? And I'm going to ask you to say this with me. I'll read it first. The largest collection of new scientific discovery that has ever been written. Okay? So just so you can kind of really think about that, read that with me. The largest collection of new scientific discovery that has ever been written. Really revolutionary. And that's why I'm so excited about it. And that's the end of my slideshow. So thank you very much for your attention and participation. And if you have any questions, we do have some books for sale in the back if you want. They were going to have me charge, I think they're on the website at $89, and they were going to let me sell them for $80, but because they didn't change the system, I'm actually selling them at the price they sold them at their last big event, which is only, I think, $69, so close to $70. So it's the best deal you could ever get. If you want it, and there's no shipping either, because if you buy it on the internet, there's an $8 shipping fee. We also have the rock kits there. The rock kits that the UM is selling right now has 27 different rocks and minerals. It has some shark teeth, lots of amazing rocks, and this little booklet that it comes with goes through and talks about each of those and explains how they prove. There's the pink coral sand we passed around, and the microscopic, you can see it's quartz-based crystals, right? Because the ones that aren't all covered with the pink are clear. What's that? Oh, so these, how much are? Oh, I think these are 120 on the website, but I think they're on our price for 75 today. So, and then the summary book is $5, or you get it free if you buy the book. So they've been selling these for a few months, but these were put together this week probably. But yeah, it's got some of the sandstone. This is a fairy stone. Oh, it even has the little piece of the basalt that's melted, because that's such a revolutionary claim. Yep. So. Yes, please. That's wonderful.
I'm just kind of chipping away. The book is as slow as I can, but
I know it takes a long time. I'm so lucky that I found it 7 years ago.
Yeah.
It took me, but I teach it in my class. Yeah. Yeah, that's fine. Thank you.
So, what I studied about Albert Einstein, some of his theories were proven in World War II.